scorecard. Okay. Namo Vishnu Padaya Krishna Prestaya Bhutale Srimate Bhakti Vedanta Swami Namine Namaste Saraswate Deve Gauravani Pracharine Nirvishesha Shunyavadi Paschatya Deshakarine Jaya Shri Krishna Chaitanya Prabhu Nityananda Shri Advaita Gadadhara Srivas Adi Gaura Bhaktavrinda Hare Krishna 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 Hare 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 Rama 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 Hare Hare. Hare Krishna. Welcome all. So let's start with our today's discussion on Learn Gita, Live Gita. We are reading chapter number 2, section 2. Yes, so in the last discussion we discussed about the concept of infinity as studied by George Cantor, right? As understood by George Cantor. And today we are going to see infinity in Vedanta. Means what is the concept of infinity as discussed in Vedanta. Vedanta means the Vedic literature, the philosophical part of it. As we discussed, Vedic literature has got rituals and philosophy. So we are discussing philosophy. That part is called Vedanta. Okay. Anybody has any question from last class? Oh, rational versus irrational. Why do we say? Okay. If you take any two rational numbers, how many irrational numbers can you find in between? If you take any two rational numbers, how many irrational numbers can you find in between? Infinite. Okay, take them very close. Take them very close. Like, let's say one is 1, other is 1 upon, one is 0, other is 1 upon 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, like, put as many zeros as you want. Between these two rational numbers, how many irrational numbers are there? At least one. And at most? At most infinite. Good. Good understanding. Good answer. Now, take any two irrational numbers. Let's say one is, okay, give me two irrational numbers which are very close. Give me two irrational numbers which are very close to each other. Just like I give you an example with rational numbers, 0 and 1 upon 1, 0, 0, 0, 0, 0, 0, as many zeros as you want to put. These two are rational numbers. So give me two irrational numbers which are very close to each other. Nobody's answering. Give me two irrational numbers which are very close to each other. No, which are very close to each other. Under root 2 and under root 2.000001. It is possible under root of 2.00001 comes out to be a rational number. Can it happen? Right? It can happen, right? Under root of 2.0000001 comes out to be a rational number. Can you guarantee that it's an irrational number? You have to guarantee that it's an irrational number. If you can construct irrational numbers, then we can proceed our discussion. Otherwise, if you cannot construct irrational numbers, how will you? Under root 2, 1 upon under root 2 to the power 1. What is the difference between these two? Root 2 is root 2 and 1 upon root 2 to the power very large number will be almost 0, right? So you're taking essentially something very close to 0 and under root 2. The gap is still very large. I want very small gap. Under root 2 and under root 2 to the power 1.000001. Can you ensure that under root 2 to the power 1.00001 is an irrational number? Under root 2 to the power 1.00001. Can it happen that it comes out to be a rational number somehow? Let's say if I take a log and okay, I think yes, I think I got two good answers. One is from Dheeraj Prabhu. He says under root 2 and replace a decimal number far away in root 2. Okay. And Archit Prabhu says under root 2 plus, under root 2 comma under root 2 plus essentially 1 upon very small number, means 1 upon 0, very small number. Square root 10 and pi. There are finite difference. You are not changing the difference. Okay, I think I got two good answers. One is by Dheeraj Prabhu, who says under root 2, and basically when you say replace a decimal number far away in root 2, you are essentially saying under root 2 plus 1 upon 1000000 something, right? So basically if you add a rational number to an irrational number, the outcome is an irrational number only. So when you say 0 comma 1 upon 10000 something, 0 comma 1 upon 1 plus, 0 comma 1 upon 10000 something, if this is your thing, just add under root 2 to both these terms, it's an irrational number. Both are irrational then, right? If you add irrational with rational, outcome is irrational. Okay, so this is what the answer Dheeraj Prabhu has given. Ajit Prabhu has given similar answer. Okay. Pi and root 10, they have a finite difference. You cannot make them arbitrarily small. Okay. So good answers. So you are thinking nicely. Okay. Now we have to prove that we cannot. Okay. Can you rephrase when I say you have to prove that you cannot count all the irrational numbers, or number of irrational numbers is larger than the number of rational numbers. Means the cardinality of irrational numbers is larger than the cardinality of rational numbers. In other words, the cardinality of irrational numbers is larger than the cardinality of natural numbers, right? Because you know rational numbers and natural numbers, they are 1:1 correspondence can be established. Okay, I think I gave the answer. So basically you have to prove that you cannot find a way to count all the irrationals. Basically, which means you cannot find a way to establish 1:1 correspondence between all the irrational numbers. No, I mean the irrationals and the natural numbers. This 1:1 correspondence cannot be established. And there is a very nice proof given by, I think, Cantor himself. I don't remember. Okay. So the proof goes like this. I think I can share my screen a little differently and then I can write on a notebook. I have to share a writing pad. Let's say this one. I have to share my screen differently. Mm. Can you see my screen now? Can you see a blank screen? Yes. Okay. Let me write here. I mean, today's discussion is very mathematical. I'm sorry for that if you cannot appreciate that, but I hope at least somebody will appreciate. Okay. So we are going to prove that we cannot count the number of irrationals. Okay. Let us say these are our natural numbers. 1, 2, 3, 4. These are our natural numbers. And I find a way, let us say, hypothetically, I found a way to count irrational numbers. And this is my first irrational number, which is, let us say, A00, I mean, let's say 0 point, because 0 point A00, A01, A02, and so on up till infinity, because irrationals don't stop. Then 0 point A10, A11, A12, so on. And in this way, 0 point A3, okay, okay, fine, 02, A12, A13, and so on, right? In this way, I can enumerate all the rationals, means I can establish a one-to-one correspondence between natural numbers and the irrational. Now, if you are intelligent, you can prove that there exists an irrational number which is not there in this set. There exists an irrational number which is not there in this set which we have enumerated. Can you see that? Can you construct an irrational number which is not there in this set for sure? Root of 2. No, root of 2 can be there. Okay, means ignore the 0 point part. Means let's say under root 2, take only the part after the decimal. 1 point you ignore. 1 point, what is it? 1.414, right? So you ignore this one part, 0.414, let's say. So you can take A00 as 4, A01 as 1, A02 as 4, and in this way keep filling all the entries, and you find this is an irrational number which is equal to root 2. I mean minus 1, okay. But I can choose my A0, A1, A00, A01, 02 appropriately to represent any irrational number, right? But prove that given this set, there exists an irrational number which is not there in this set. Anybody? Okay, I think it is a tricky thing. Replace row of any number with column, then that number does not exist. Replace row of any number with column. Replace row of any number with column. What does that mean? Means you take a transpose of this whole thing. If it is a matrix, okay. No, it is possible that this matrix is a symmetric matrix, right? I can choose A00, A01 in such a way that it's a symmetric matrix, and then if I exchange the row and column, then the number will still exist. Good try, good try. You're very close. You're thinking in right direction. Okay, maybe I'll just disclose because we don't want to spend all our class on discussing this. Let's consider this example. Actually, we can construct infinite number of irrational numbers which are not there in this set. I'm just giving one example. A00 plus 1. Basically, I'm adding to this digit. Then A11 plus 1. Then A22. In this way, construct a number. This number is certainly not equal to this number, right? Because this is A00 and here we have A00 plus 1. So this number, let me call it X. So X is certainly not there, not equal to the first number, right? Can it be equal to second number? No, because A11 plus 1. So this entry will mismatch. Even if A10 is same as A00 plus 1, still this entry will mismatch, right? Similarly, X is not equal to third number because this A1, A33. Whatever. I did not write it properly. This is A20, 21 and 22. Right? Okay. Two zero, 1 and 2 2. So this third entry is A22 plus some other, means this digit is not same as this digit. So this number is certainly not equal to this number. So in this way you construct a new number which is not equal to any of these numbers. Right? So this means that we cannot count irrationals. Means we cannot establish a one-to-one correspondence between irrationals and the natural numbers. Right? And there are further complicated proofs to show that Dheeraj is saying take a number diagonally. Yeah. Take a number diagonally. Yeah, that's what we did, right? We took a number diagonally and we replaced every element so that it is not equal to any of these numbers. Okay. So there are more proofs to show that how the cardinality of irrationals is one more than the cardinality of not one more actually. It's the next level of infinity. Anyway, so we won't go into that. But at least we know that number of irrationals is more than the number of rationals. Okay. Let's go back to our discussion. Okay, so that's why Cantor said, I can see it, but I cannot believe it. That how rationals and natural numbers are same in size, but further irrationals are of different size. So between any two numbers there are infinite numbers, then adding infinite times gives infinite. Yes. So our mathematics completely break down. Our mathematics will completely break down. Actually you can show, I can confuse you even further. Okay, take a line segment of, let's say, take only numbers between 0 and 1. I'm giving you this more complicated example. Take a line or take a set between 0 to 1, take all real numbers, right? On the other hand, you take a real line, a line of all the real numbers, basically from minus infinity to plus infinity. Okay, it's not infinity, but from this end to that end. Which one has got more number of real numbers? Or just rationals? Just rationals. Which one has got more number of rational numbers? This. Okay, I can say real numbers. Why to confuse? Take real numbers. These many real numbers in the between 0 to 1 and all the real numbers on the number line. Which set is bigger? Rajkumar Prabhu can answer. Did you get the question? Between 0 to 1, how many real numbers are there? That set, and all the real numbers, like on the number line. Which one is bigger? Which set is bigger? Okay. Let me ask a simpler question. One set is between 0 to 1, other is between 0 to 10. Which set is bigger? Real numbers between 0 to 1 or real numbers between 0 to 10? Which one is bigger? Second is bigger. Anybody else? Rajat Prabhu is saying equal. Prove it. How they are equal? Second one is bigger. Prove that second one is bigger. Or prove that they are equal. So both sides have to prove. Whoever can prove, that side is the winner. So prove either one is bigger or the other is bigger. Or if they are equal, then prove both are equal. Okay. Yeah. Okay. Dheeraj Prabhu is saying, by 1 to 1 corresponding number between 2 to 10 are not mapped. Yes, good logic. And Rajat Prabhu was saying they are equal. Can you prove that they are equal? Yeah, I am just asking mathematics questions. I am not even asking Bhagavad Gita. Simple, it's mathematics and you are all experts. Okay, I will go back to this. I'll go back to my writing pad. Can you see my writing pad now? Yes, okay. So, one set is, let's say, numbers between 0 to 1. So, let's say x belongs to 0, 1 and y belongs to 0, 10. So this is the one-to-one correspondence. Can you find any number in the set, in this set, let's say this set is the y set. Can you find any number in the y set which is not there in the x set, or vice versa? Can you find any number in the y set which is not there in the x set? Which one is that? Which number? Rajkumar Prabhu is saying yes. Which number? Which number is there in the y set which is not there in the x set? If I use this mapping, I can map every number of y to a number in x. 1 onwards, let us say I take 2. So corresponding number is 2 upon 10, 0.2, which is there in x. I take 2.5, then corresponding number in x will be 2.5 upon 10, means 0.25. Every number is there, right? So now Dheeraj Prabhu can answer. Is this mapping not alright? Dheeraj Prabhu can answer. Is this not a good mapping? So corresponding to every number in capital X, I have a number in capital Y, and vice versa. One-to-one mapping. Didn't understand questions. Okay. The question is, which set is bigger? 0, 1. All the real numbers inside 0, 1. Is this bigger than all the real numbers between 0, 10, 0, 1 and 0, 10, which has got more number of real numbers? Set X, which has got real numbers between 0 to 1, and set Y which has got all real numbers between 0 to 10. Which is bigger? Which set is bigger in size? Between 0 to 1 you cannot find them. Means if I take my Y equal to let's say 0.5, then corresponding X will be 0.5 upon 10, which is 0.05, right? So I can find a corresponding X. Both are same, yes. So I have to just find a proper mapping, and this is one mapping which will show you that how both sets are exactly same. Okay, now is this question clear, Rajkumar Prabhu? So you asked this question. You asked this question that between any two numbers there are infinite numbers, then adding infinite times gives infinity. But no, it is same infinity, right? I added this set 10 times, but still the size has not increased. Size is still the same. Okay, now my question is more difficult. Let us say my Y is, so I will call it as Y dash, let us say. Now my Y dash is equal, belongs to 0 comma, actually we can't write it infinity, okay, means basically all real numbers greater than 0. I will say are positive. So which one is a bigger set? R positive or 0 comma 1, basically a capital X. So which is bigger? R positive, the size of R positive and the size of X. So which one is bigger? This is bigger. Oh, I don't know why my pen is not moving properly. Or this is bigger, or they are equal. Which one is bigger? R positive or X? So X is 0 to 1 and R positive is infinite times 0 to 1. So which one is bigger? If we take any number in R, then R upon R plus 1 will be there in 0 comma 1. Okay, if I take any number in R, then let's say if I take 1 upon 2, if I take 5 upon 6, if I take 100 upon 101, if I take 1 million upon, yeah, Abhishek Prabhu is really very clever, very nice mapping, very nice way to present this thing. Thank you. Yeah, it's a very nice answer. If you take any number Y dash, then Y dash belongs to real positive, then Y dash upon 1 plus Y dash will be always in X, capital X. Okay. Good answer. So basically you're saying my Y dash upon 1 plus, this is my X. Good. Yes. So, which means Abhishek Prabhu has just proved that infinite times if you take infinity, it still remains the same infinity. That is like, that's what Cantor said. I can see it, but I cannot believe it. It is unbelievable. Like when I also saw for the first time, I was really like taken aback. Oh, what is this? Is it really true or am I doing some mistake? Now since I have been seeing it for some time, I don't get so much excited about it, but actually it is really very exciting. Okay, let's see what Vedanta talks about infinity. Vedanta says, somebody has a question. Irrational number are infinite or more than infinite. Okay. As I told you that there can be bigger or smaller infinities as per George Cantor's definition. So there can be, so rational numbers, their size is 1 infinity. Irrational numbers, their size is 1 higher level of infinity. And you can create sets which are even bigger infinities. But okay, that is mathematical notion. Here in the Vedanta, we just stick to one understanding of infinity, means infinite times infinity is taken out. So I have not read in this understanding levels of infinity. Means infinity can be bigger or smaller, but maybe it is there, I am not sure. But I have, until now, this is my simple understanding. Okay, so let us say, let us say what Vedanta says. So Vedanta talks about infinity in many ways. The absolute infinity, what George Cantor talks about, not potential infinity. The absolute infinity. The nature of the infinity is spoken in Upanishads, in Isha Upanishad. In Sri Isha Upanishad, the invocation mantra, the first prayer to the Lord is Om Purnamadaha Purnamidam Purnat Purnamudachyate Purnasya Purnamadaya Purnamevavashishyate. So it means, the personality of Godhead is perfect and complete. Oh, screen has to be changed. Okay. Fine. Okay. Sorry about that. Let's see. Yes. The Om Purnamadaha shloka, the translation is like this. The personality of Godhead is perfect and complete. Om Purnamadaha and Purnam Idam. Purnam Idam means, and because He is completely perfect or completely infinite, all emanations from Him, such as this phenomenal world, are perfectly equipped as complete wholes. Like Purnamadaha, Purnam Idam. Idam means this world. Purnam Adaha means Krishna or the Supreme Lord. He is Purnam, means infinite, and this phenomenal world is also Purnam. And then it goes on saying, Purnat Purnam Udachyate. So whatever is produced of the complete whole is also complete in itself. Which means, this is an infinite set, and what set comes out of it, that is also infinite. Right? But then does it mean this set has reduced? No. Purnasya Purnam Adaya Purnam Eva Avashishyate. So Purnasya means out of the Purnam, if we subtract the Purnam, then also Purnam is left. Avashishyate means left. And so because He is the complete whole, even so many complete units emanate from Him, He remains the complete balance. Which means Krishna does not diminish even when complete universes are taken out of Him. Like each universe is complete in itself, and Krishna, the source of all universes, is complete. But even if infinite number of universes come out of Krishna, still Krishna is not diminished. He still remains the complete. So this is very beautiful understanding. This is very beautiful understanding of Isha Upanishad, which defines the concept of infinity. Like nobody can even imagine. Like I told you, one professor in Japan, he's a professor. You can imagine, he's a professor. In the year 2008, I went to Japan in 2008 for my internship when I met him. And I told him this concept that the happiness in the spiritual world, it keeps increasing, it never diminishes. And he said, this is not possible, because how can something just keep increasing and never decrease? Means he did not know the concept of infinity. He did not know that something can keep adding and still the set remains the same. It is not overflowing. Right? So that was very amazing, very amazing. And this is what is unimaginable understanding. Like how can somebody come to this conclusion? That person must be really super genius who can give this concept that even if you take out complete holes from the complete whole, the Krishna, still Krishna remains the complete balance. He does not diminish. This concept is really marvelous. This is unimaginable because in material world we never see this. Even if you take ocean, even from oceans you can take lots of water, right? And you may think ocean won't decrease, but still if you take really big chunks of water, then really ocean will decrease, right? And people are talking about polar ice melting and the ocean levels are going up. So, right? Oceans are also not infinite; they are also finite. When the polar caps or the ice in the poles will melt, the level of ocean will increase. This means that even the ocean is not complete. The ocean is not infinite. It can increase and decrease. Okay. So this explanation is quite remarkable, as we can observe that infinity is hidden even within his creation that makes this world to be self-organized. So this world is also infinite. This phenomenal world is also infinite. Simultaneously, the infinite remains the same even after infinite emanations come out from him. Consider the example of the original cell that comes into being by the combination of half the mother cell and half the father cell. This cell has all the information hidden within it that makes it grow through the process of cell division to become a very complex biological body consisting of hair, nails, skin, nerve cells, and so forth. Even after years of research and endeavors, life science researchers are unable to comprehend a single cell. Rather, the mystery of the cell remains as complex as the gigantic cosmos. Thus, it is imperative that the process of understanding the natural phenomenon is not to control it, but to be aware of the infinite beauty of the infinity through Krishna's creations. Okay. Very nicely Sir has put up this. So Sir is saying, first Sir is telling, really this world is infinite. And if you see, just one cell is so complicated, just single cell, it's like infinite world inside it. Sir is giving an example. You see, our body has come, all the information, like here, they perform different function, they have a different structure, my skin has a different structure, different function, so many organs have different structure, different functions. But all this information was there in that one cell, right? And similarly, you can see, as we discussed few days ago, the tree, all the information is there in one seed, right? Just you put that seed, if you want to take the entire, let's say, mangoes of India, just take one seed and take it to some other planet or some other country where you can plant it and it can grow. Then you will see this entire same mango, everything is there. It means all that information which is there in India, in that mango tree or mango fruit, everything is there in that seed, very small seed. Mango seed is even still bigger. You can take even smaller, let's say apple. Apple seeds are really very small, right? And that information is there in that seed. So this, and what to speak of this cell. So when you see humans, they start from one cell, and that cell has got all the information. Like if you ask how the hair grow, it's there in that cell. How does the heart function? The answer is there in that small cell. Like this is really amazing. Then Sir is telling here, like you remember a few days ago we discussed why are we studying this complex artificial intelligence, complex creation. So the purpose is not to control or to exploit, but to be aware of the infinite beauty of the infinity through Krishna's creations. That how Krishna has created this world, and so we can appreciate. So Prabhupada often says, everybody can say God is great, but how great He is, who can tell, right? For example, I can always say world is infinite, but Newton can really say. Newton says, I have been just roaming on the shore and collecting some seashells, but the ocean of knowledge lies in front of me, still unexplored, right? Newton can say that because he has seen that small shell, he has understood that small shell very nicely. And from there he can appreciate how much beauty is there in the, or how much knowledge is there in the infinite or huge ocean, right? Similarly, when we study this, let's say today we studied one small concept of infinity, which is very, which looks like very, like we have understood it, right? We may think we have understood it, but even this much, when we appreciate, I mean, this helps us to appreciate the complexity of the creation, or the infiniteness of Krishna, right? So that is the purpose, that a person who has this much realization, he can appreciate the bigger thing. But if a person who has no realization at all, he cannot appreciate anything, right? Because he has nothing in his pocket. So that is why we should try to appreciate, even if possible, a little bit glory of Krishna, and that will help us to appreciate the infinite beauty of Krishna. Hare Krishna. I think that is, we'll read the next part tomorrow. We're going very slow over this. Maybe, I don't know, how long will it take? Okay, conclusion. So, okay, not much. Yeah. 3-4 more pages. But every paragraph what Sir has written is very deep in this, and especially I have been reading this for many years, and whenever I read, I find something new. Like today, I found this point which is very nice, which I find earlier I didn't appreciate that much. This point that it is imperative that the process of understanding the natural phenomenon is not to control it, but to be aware of the infinite beauty of the infinity through his creation. This point today I am able to appreciate in little bit different way. So, in much different way actually. Yeah. So this is the thing, that this chapter, every paragraph is very deep. Hare Krishna. Anybody has any questions? Okay, I think fine, then we'll meet tomorrow and we'll discuss further. Thank you. Hare Krishna.